Oh, record. Boom. So last class we learned about product rule and quotient rule. Today we learned another rule called the chain rule. So if it's the rule for taking the derivative of a composite function, and a composite function is a function made of multiple functions. Okay. I don't want to make it sound too confusing though, so let's just look at the chain rule. So if we're given a differentiable function, and the exponent is any real number, the function u of x to the n, then the derivative is going to be n times u to the x to the n minus 1 times u prime of x. Now, to keep this really, really simple, what all of this means is that when you do the chain rule, it's going to be the derivative of the outside function right here, derivative of the outside function. The inside function will remain the same, and then you will multiply it by the derivative of the inside function. So keeping it really simple, it's the derivative of the outside times the derivative of the inside. That's as easy as we can explain chain rule. Okay. And of course, we'll have lots of practice today. So derivative of outside times derivative of inside. And then since we know the derivatives of e to the x and the natural log, these are the chain rule derivatives for e to the g of x and the natural log of g of x. So if you're ever given e to some function g of x, the chain rule derivative is going to be e to the g of x times g prime of x. And then the chain rule derivative of the natural log of some function g of x will be 1 over g of x times g prime of x. Or to keep that derivative really simple, the derivative is just g prime of x over g of x. And we'll see those as we move on. But that's the chain rule. Derivative of outside times derivative of the inside. Okay, let's try it out. So for the first one, we want to know what is f prime of 3x plus 1 to the fourth. So by the chain rule, that 4 comes down. The inside stays the same. My new power is 3. This was the derivative of the outside function. And now we are going to multiply it, choose a different color, by the derivative of the inside. So the derivative of the inside, the derivative of 3x plus 1 is just 3. And that's derivative of outside times derivative of inside. And all we have left to do is clean up, which means I'm going to take this 4, multiply this 3, and it's done. We get 12 times 3x plus 1 to the third, and we do nothing else. Any questions on that?
What about the 3?
The what?
Is that because the 3 is a constant, so it just zeroes out?
Oh, wait. So
Green
remember, we took the derivative of this outside function, right?
Correct.
All of this.
Mm-hmm.
And then you multiply it by the derivative of the inside. What is the derivative of 3x plus 1?
It would just be 3 because the 1 will be zeroed out and the x will be down, so it'd be 3.
There you go. There you go.
But when you drop it all the way down where it says 12 and then, you know, x plus 1, where did you put that 3?
What's 3 times 4?
Oh, I thought you were doing the inside 3 for some reason.
No, right?
Okay. Got
There you
you.
go.
So just that.
So
Okay.
when I label this as inside, I'm claiming it as it was the derivative of the inside.
Okay.
Right? Well, I can't spell derivative. Okay. All right. We'll try it again. Next one. Find y prime if y equals 3 times x cubed plus 4 to the 7th. So here we go, y prime. And by the chain rule, this 7 will come down, multiply that 3. So we'll get 21. The inside stays the same, and my new power is 6. That's the derivative of the outside. Then we multiply it by the derivative of the inside. What's the derivative of the inside?
3x squared.
3x squared. There you go. That's chain rule. And now just do 21 times 3x squared.
63x squared.
That's it.
Times x cubed plus 4 to the 6th.
That's it. All good? Any questions on that? All right, not bad. Keep moving. C, 4x plus 3 to the 1/2. So the derivative by chain rule, you're going to get that 1/2 to come down. The inside stays the same. You take 1 away. 1/2 minus 1, I get negative 1/2. And then you multiply it by the derivative of the inside. What's my derivative here?
4.
Just 4. Perfect. There you go. Calculus is done. Algebra on. 1/2 times 4.
2.
There you go. So we get f prime of x equals 2 times 4x plus 3 to the negative 1/2. Now again, that's a great answer, but if it asks you to rewrite it, you can rewrite it as 2 over 4x plus 3 to the 1/2. Okay. All good on that one? Okay. Go, go, go. Again, x to the 5th plus 2 to the negative 3. By chain rule, we get f prime of x. That negative 3 is coming down. The inside stays the same. You take 1 away. There's the derivative of the outside. Now, what's the derivative of the inside?
5x to the 4th power.
5x to the 4th. There you go. And then negative 3 times 5x to the 4th. Negative 15x to the 4th times x to the 5th plus 2 to the negative 4. Perfect. Of course, you could rewrite it. Negative 15x to the 4th over x to the 5th plus 2 to the 4th. Okay. All right, E. D over dt of 1 over t squared plus t plus 4 to the 3rd. So we are just going to rewrite this. We're going to flip it to the top. and I'm going to rewrite it as d over dt of t squared plus t plus 4 to the negative 3, which means now we can apply the chain rule, and we will get the derivative of the outside, negative 3. The inside will stay the same to the negative 4. There's the derivative of the outside. Now multiply it by the derivative of the inside. What do we have?
2t.
2t plus
1.
1. Remember, the derivative of that t is 1. Okay. And then multiply this negative 3 by that 2t plus 1. I'm not going to distribute it just yet. I'm going to just rewrite it as negative 3 times 2t plus 1 times t squared plus t plus 4 to the negative 4. I just put them together. So now this can actually be an acceptable answer. Or, once again, our rewrite is going to be negative 3 times 2t plus 1 over t squared plus t plus 4 to the 4th.
Why don't we solve it? Like negative 3 over to 2t and plus 1.
You could. It's just extra work.
I got you.
So this is as simplified as it gets, but you're right. Let's say if my math lab wants you to go further, you would distribute that negative 3, and that would be your answer. So you could have negative 6t minus 3 over all of that. But I never see a need to distribute if I don't have to. If you feel the need, then go ahead and distribute away.
I feel no need for that.
That's done. Like, why do extra work? This is as simplified as it gets. Okay. Any questions on that? Okay. Keep going. Now find dH over dW. Find the derivative of h with respect to w if hw equals the square root of 3 minus w squared. So we have to rewrite this function because we can't take the derivative in this form. So we will rewrite it as 3 minus w squared to the 1/2. There we go. And then we'll say dH dw, the derivative. That 1/2 is coming down. The inside stays the same. You take 1 away, we get negative 1/2. And then we multiply it. And what is the derivative of the inside?
It'd be
Negative 2w.
There you go. Negative 2w. There you go. Then 1/2 times negative 2. Negative w times 3 minus w squared to the negative 1/2. Okay, again, suitable answer, but we can always rewrite negative w over 3 minus w squared to the 1/2. All right. What's up?
On the first part of this problem, how how did you flip that where it was 3 minus w to the second to 1 over 2? How did you flip that? Is there some kind of rule for that?
Yes, remember that from our algebraic properties, if you ever have the nth root of x, it's always rewritten as x to the 1 over n. So if this is the square root of x, well, to rewrite that, you'd get x to the 1/2.
Okay, thank you.
Yep. Okay. All right. Again, G. Find y prime if y equals 2 times x cubed plus 6 to the 5th. So by the chain rule, we get y prime. This 5 comes down, multiplies the 2. So 10 times the inside, which stays the same. You take 1 away, you'll get 4. There's the derivative of the outside. And then we multiply it by the derivative of the inside, which is
3x squared.
there you go. Combine 10 and the 3x squared and 30x squared times x cubed plus 6 to the 4th. There it is. And that one was easy. All right. D over dt of 3 times t cubed plus t squared to the negative 2. So this just says take the derivative of this expression. So this negative 2 comes, multiplies this 3. We get negative 6. The inside stays the same. You take 1 away, and we get negative 3. There's the derivative of the outside. And then what is the derivative of the inside?
3t squared plus 2t.
Very good. There we go. And then 6 times all of that, just like the one we did on the other page. I'm not going to put them together, or I'm not going to distribute them together. I'm going to rewrite it just as negative 6 times 3t squared plus 2t times t cubed plus t squared to the negative 3. Okay. Again, suitable answer. But we can rewrite as negative 6 times 3t squared plus 2t over t cubed plus t squared to the 3rd. And distribute that negative 6 if it feels right to you.
We only
What
do
was-
it that way if it's d over dt like that, right? As far as
Exactly.
the option.
Exactly. Because there's no y equals or f of x equals. This d over dt just says, hey, take the derivative of this function. That's it. Good. All right. Any other questions on that one? All right. All right. So now all of those may have seemed easy, right? So maybe this one's a little more complicated, but not too crazy. So this says d over dx of 2x squared times x cubed minus 3 to the 4th. So this just says take the derivative of these two functions. And what we realize is that we have two functions multiplying each other, which means we are going to have to apply the product rule to this derivative. So this is going to be a derivative that involves a product rule and a chain rule. So when we do product rule, 2x squared is going to be f. And then g is going to be x cubed minus 3 to the 4th. And then we will take the derivative of f, which is 4x. And then we'll take the derivative of g, which will use chain rule. Oops, hit the mic. Which will use chain rule, which means you'll get 4 times x cubed minus 3 to the 3rd times, what's the derivative of that inside?
3x to the squared.
Good. And now let's just go ahead and clean g up, or g prime, and you'll get 12x squared times x cubed minus 3 to the 3rd. Okay, so that's the derivative of f. That's the derivative of g. And now to be proper, since it doesn't have a y equals or f of x equals, we have to start off by writing this statement again. D over dx of 2x squared times x cubed minus 3 to the 4th will equal, and now we follow our product rule. Oh, I forgot my prime, didn't I? There we go. F prime g, 4x times x cubed minus 3 to the 4th plus g prime f. 12x squared times x cubed minus 3 to the 3rd times 2x squared. All right, and now clean up. This is fine as it is, 4x times x cubed minus 3 to the 4th, but on the right side, we can do the 12x squared and the 2x squared together. Which will give me 24x to the 4th times x cubed minus 3 to the 3rd. Now, I believe that my math lab is going to make you factor this. It's not going to let you leave it like this. If it does, that's nice. But in the meantime, let's factor. And let's start with our numbers. I have 4 and 24. What could I factor out?
4.
6.
Of 4, right? We're looking for a greatest common factor. So between 4 and 24, the greatest common factor would be 4. And then x and x to the 4th. What could I factor out?
X.
An x. And then x cubed minus 3 to the 4th and x cubed minus 3 to the 3rd. How many of those could I factor out?
3.
3. Good. There's my greatest common factor. And now we are taking this from here. What would that leave me with?
6x.
Well, when you factor
I think
4x from
x.
4x, they'll cancel, right?
Just one exponent, really.
So you'll just be left with x
X to the
cubed
third
minus 3. There you go. Good. Plus, now we do it again. You factor all of this from all of that. So 4 factored from 24, you'll get
6.
6. X factored from x to the 4th,
X to the 3rd.
x to the 3rd. And x cubed minus 3 to the 3rd from x cubed minus 3 to the 3rd will
Cancel out.
cancel. There you go. Factored. Now, one last cleanup. you get 4x times x cubed minus 3 to the third times, and you can add this x cubed and that 6x cubed, and I'll get 7x cubed minus 3 done and done. Hey, not bad. It's the algebra that kills, right? Okay. Any questions on that before moving on? Okay. All right. Now we come to these crazy ones. F of x equals negative 5 times e to the 12x. So we're going to be using that new chain rule derivative. So if I had, I'll just say if I had d over dx of e to the some function g of x, well, from the first page, the chain rule derivative would be e to the g of x times g prime of x. So that's the formula we're going to use for this one. So when I say f prime of x, and we're only looking at the e function, the negative 5 is going to hang out outside. And by that derivative formula, what is the chain rule derivative of e to the 12x going to be?
This.
It's going to be the same thing times the derivative of the exponent. What's the derivative of 12x?
12.
12. There you go. That follows that formula exactly. And now all we have to do is multiply that negative 5 by that 12. Negative 60 e to the 12x. There it is. Any questions on that?
Can you hold on just a second? I'm catching up with the notes.
Sure. No, you're good.
Okay, I'm good to go. Thank you.
Yeah. And now we have the natural log. So again, we learned a new derivative formula on the first page. We had the natural derivative of the natural log of some function g of x. That derivative is going to be g prime of x over g of x. The derivative of the inside over the original inside. So here we go. All we're looking at is this piece. So that 10 will be waiting outside. So 10 times, and what is the derivative of the inside?
9x to the 8th power.
And you put it over the same exact inside. There you go. Multiply that 10 to the 9x to the 8th, and you'll get 90x to the 8th over x to the 9 plus 2. Done, done, done.
So all you did was you multiplied the 9 by the 10, and that gave you 90x, the 8th power. Okay, got you.
That's it. Any questions on that one?
The ln, where does that play a role in?
That's just the natural log.
Okay.
So, we have logarithms, common logs, natural logs. So this is just a derivative. But if you're wondering, like, what is its applicational use, then it's able to compute extremely large values into a smaller numerical input. if you were wondering that.
Yeah, like the lotto or something like that, right?
More like you could, but it'd be more like earthquakes. So when
Gotcha.
like an earthquake hits LA and they're like, oh, that was just a 7 on the Richter scale. No. Like there's more behind that. Like earthquakes are measured in I think like millimeters or something. So if you shake a whole city, a 7.1 on the Richter scale is like 500,000 or 500 million millimeters or something. So it's pretty cool. You should look into it.
Definitely will.
But all they give us plain simple Americans is that was a 7, and we're like, oh my god, on a rate of 1 to 10, that was a 7. So that's why natural logs and logs are pretty cool, because they'll take these extremely large values and put them into a smaller amount for us to understand. And logs do deal with business applications as well. Okay. All right. Last one. The total cost in hundreds of dollars of producing X cameras per week is C of X equals 6 plus the square root of 4X plus 4. Our domain is between 0 and 30 cameras. A, find the derivative of the cost function. Okay, we'll start there. So A, first thing we have to do is rewrite it, because we can't take the derivative in that form. It's going to be 6 plus 4x plus 4 to the 1/2, which means now it's in the perfect form. So we take that derivative, and what's the derivative of 6?
0.
0 plus, and now we chain rule derivative 4x plus 4 to the 1/2. So we get 1/2 times 4x plus 4. You take 1 away and we get negative 1/2. And then multiply it by the derivative of the inside, which is just
4.
4. There we go. And 1/2 times 4. We can get rid of that 0, and you'll get 2 times 4x plus 4 to the negative 1/2. Again, suitable answer, or rewrite it as 2 over 4x plus 4 to the 1/2. Okay, now there's the derivative of the cost function. And now B, all it wants us to do is plug in 15 and 24. And interpret, of course. So B, C prime of 15, C prime of 24. All right, and Desmos time, why not? I don't even have it open. Oh my goodness. Oh yeah, this thing keeps freaking out on me. I hit the power button so it can sleep, and it just shuts the whole laptop off completely. And now load up internet. There we go. Ah, boom, boom. Okay. Let me look at my function. So I'm just going to type in my derivative. I'll just do the first form. 2 times 4x plus 4 raise it to the negative 0.5, and then change it into a table. Pick the values I want. Come on, there we go. And we're typing in 15. Oh, no, not up there. I messed it up. No, that's X. Okay, 15 and 24. There we go. So I get 0.25 and 0.2. All right, back to the notes. And now we want to know, what does all of this mean? So remember, when we're dealing with the derivative, we're just interpreting the slope at a certain X value. So remember here that X is the number of cameras, and whatever the output is the cost in hundreds of dollars. So this says that if we produce 15 cameras, is that a positive output, or is 0.25 a positive or a negative output?
Negative.
Positive.
Positive, right? It's a positive output. So this means that if we produce 15 cameras, cost is going to increase because it's a positive output. But remember that cost is in hundreds of dollars. So cost isn't increasing by 25 cents. Cost is increasing by how much money?
25.
Good.
2,500.
25, just $25, right? So if we produce 15 cameras, the cost will increase by $25 per camera. And then now, if we produce 24 cameras, 24 cameras, cost will only increase by how much?
20.
$20. And that's it. Okay. So remember, if the output, so when you have a derivative and you're plugging numbers in, if the output is positive, that always represents increasing. If the output was negative, that always represents decreasing. But other than that, that is the chain rule, and we are done. If you have any other questions, stick around.
So that's it for today.